Hello again. So we were talking with the students about the Bachelor Degree Written Exam, the operating system, and we were looking at the subject that was given in 2018 in July. And we were looking at this problem, which deals with FIFO as a way of communicating between processes. And even though the students didn't ask, I was thinking to do a video for whomever it may concern about the B, C, and D points here in the problem. We won't draw the diagram. If you want me to draw the diagram, just let me know and I will do that as well gladly. But we will look today more on the synchronization mechanism that pertain to FIFO. For that we will implement the code, and first we will look at the requirements a bit, and we see that we have to have some FIFO which are transmitted as parameters to the f function as a and b, but here in main we see that the f function is given the first two arguments from the command line, actually either the first two or the fifth and the sixth. And in all the three situations, we have P and Q as FIFOs. So first we have to create those FIFOs. It is always a good idea to go through the manuals, and if you are typing man minus key from keyword FIFO, we see that we get a lot of information at different sections of the manual. The sections are given as numbers in the parentheses. But we see that we have something here as cube. We are interested only in a named pipe. So if you are giving the command filtered by grab name pipe, we see that we have manuals at section 1, make a FIFO, and we know that section 1 is about executable programs or shell commands. We have at section 3, make a FIFO special file, a name pipe, and at section 3 we have library calls, functions within program libraries. And we have here FIFO at section 7. Section 7 deals with miscellaneous, including talking about conventions, and here it is more detailed, the concept of FIFO. Let's start with the 7th section of the manual. Here we can see that a FIFO is a special file, a named pipe, and it's similar to a pipe except that it is accessed as part of the file system. It can be opened by multiple processes for reading and writing. When processes are exchanging data via a FIFO, the kernel passes all the data internally without writing it to the file system. Thus, the FIFO special file has no contents on the file system, and it merely serves as a reference point so that the process can access the pipe using a name in the file system. So actually, what it says here is that the FIFO file would never contain on the hard drive or in the file system any data. So that's an important aspect. Another aspect is that the kernel maintains exactly one pipe object for each FIFO special file that is opened by at least one process. The FIFO must be open on both ends, reading and writing, before data can be passed, normally opening the FIFO blocks until the other end it is open also. This we need to remember because it will be useful in solving our problem. So let us create the two pipos that we need. As you remember, we need P and Q. The easiest way to create a FIFO file is by using the command mkfifo. So we are creating them both. As you can see here, they are created and they have the length 0, and we can go on by writing the code now. I wrote the code, as you can see here, and when we take a look at the code, we see here that we have an iteration, a for cycle that goes on depending on how many arguments do we have in a command line. So for each iteration, the function f is called, this one, and here new process is created in this function, and this is the code for the child process, the new process that is created, because here we have the return of the function fork equals to 0, but the code of the child function ends here because of this exit. So actually what happens, the child finishes within the iteration it was created. So only the parent will go on to the next iteration of the for, and actually for the diagram, if you need to know, it is what we are calling a star structure, meaning only the parent will create other processes. I added some prints to our code in order to be able to follow what's going on during the running of the program. So before each important operation, I added, for instance, here I transmitted also the I parameter, and this for iterates I times and prints tab in order to separate the processes. And here we print the PID of the current process, its parent, and we want to see here which FIFO is open and how it is open. Next, here again we have the PID and the PID of the parent and the operation where it writes in which FIFO and what does it write, and here what it reads from which FIFO and what value. Here it's printed the value which is read, and here in the parent we are printing only the PID of the process, the PID of the parent, and the iteration, and at the end we finish with the end. Now we are compiling our version with the prints, and then we are running the command ps in order to see the PID of our bash, and then we are running our program with the arguments as specified in the requirement B. So pq1x, and we see here that the PID of the parent of the first process is similar with the PID of our bash. And within the first iteration we have a child which attempts to open the P FIFO in read only and Q FIFO in write only, but it actually blocks while opening the P FIFO in read only because it waits another process to open the same FIFO in write only, and only then it can go on to the next operation. Next, we are running the same program with the arguments as specified in the requirement C, PQ1X, PQ0Y. And here we see that we have two iterations. In the first iteration we have one child which again tries to open the P FIFO in read only, the Q FIFO in write only, and only after the second process opens the P FIFO in write only and Q FIFO in read only, this process can go on from the opening of the FIFOs, and it writes in Q the value X, and then the other process, the other child of the parent process, writes in P the value Y, and then the first child reads from P the value which is printed here as Y, and the second child reads from Q the value X. So you see those two processes, they communicated between themselves using the two FIFOs P and Q. Next, we are running again the program with the arguments as specified in requirement E. So PQ1X, QP1Y, and we see here that the two processes are created, and the first one tries to open the P FIFO in read only, and it blocks here waiting for another process to open the same FIFO in write only, but the second process opens the queue FIFO in read only. So it means it blocks there waiting for another process to open the queue FIFO in write only. So both processes are blocked, so no process will be able to carry on. Hope that helped. Best of luck. Bye.